Okay, next we're going to speak about intrusion prevention system. Likewise for the CCNA level exam, just an introduction about what IPS is. So what is IPS? Again, by the name, it's a system used to prevent intrusion. Intrusion prevention system. What does it do? It performs deep packet inspections on the analyzed packets to ensure that packets or protocols used by those packets are conform with standards. So to make sure that, for example, there is nobody in the local network using, for example, trying to send HTTP traffic out from the network, but using a non-standard HTTP let's say browser, just to try to send an internet not HTTP traffic, but for example to tunnel SSH traffic over HTTP, or to tunnel RDP traffic over HTTP, or whatever else. So you have to make sure that the web traffic is per the standards, is not some kind of non-standard web traffic in there from the protocol point of view and from the application tunneling point of view. Now the headers are correct and per the RFC, because otherwise, if for example, if let's say that the user goes out on the internet and is going to try to access a specific web resource from a malicious site, and if that site returns over to the user the reply in a non-standard format, then the user's browser is going to have an exception, and when exception happens, that it means that the system is going to have an unexpected behavior, which maybe the attacker knows about it, and that's going to make the system unstable, and it's going to make it vulnerable against maybe some kind of exploits in there. And also it detects in the analyzed packets, it's going to detect and prevent malicious traffic from reaching its target. Like known malicious traffic, like known attacks, like known denial of service attacks, or resource exhaustion attacks, or any kind of well-known attacks in there. Now IDS versus IPS. So IDS was the intrusion detection system, IPS is the intrusion prevention system. So that means that IPS is the successor of IDS. And just by the name, it means that IDS could just detect attacks and produce alerts, but not take action, which means to prevent. That's why it was called intrusion detection system. It could detect attacks and alert, but it could not take action, which means to prevent the attack from happening as it was detected. Of course, the IPS came to fix that up. So IPS can actually work either in IDS mode or in IPS mode. We get to choose, which means that IPS can also prevent or drop malicious traffic as it happens before reaching its target. So it means that IPS is going to have additional actions as a result of detecting malicious traffic, as opposed to IDS, which could do only alerting. IPS can also drop the traffic, block the attacker, reset the session, or do shunning, which means it's going to signal to other network devices to actually block the attackers, the traffic. Now, traditionally speaking, IPS can be deployed in two different places in the network. So at network level, called a NIPS, network IPS, or at host level, called a HIPS, from host IPS. Now, we're going to speak in here about network IPS, not about host IPS. Cisco doesn't have a product for host IPS anymore. And even so nowadays, let's say the IPS at the host level is actually functionality nowadays which is built in into other security solutions. So the typical IDS design, just to have a better visualization of how IDS was deployed, because it couldn't prevent traffic, it couldn't prevent the attacks from happening. It means that the IDS was not setting inline of the traffic path. So like between the inside and the outside networks, like between the LAN and the internet, the IDS was not in line. So IDS was just receiving a copy of the traffic, not the traffic itself. That's why it couldn't prevent the attack, because it didn't receive the traffic as it was flowing, but a copy of the traffic. While a typical IPS design means that the IPS sits in line of the traffic path between those two networks, between the inside and the outside, which means it sees the live traffic, which means if it's going to detect any kind of malicious or suspicious traffic in there, it's going to block, is gonna drop the traffic, send an alert, block the attacker, whatever you configure it to do. So now that we know what IPS is, where did it came from, it's a successor of IDS, and how each of them worked, what are the difference between IDS and IPS. Let's speak about the IPS, an overview, and of course about NIPS. So NIPS is going to be deployed transparently as a layer 2 device. So we don't, one of the main reasons in here being that we don't want to inject it as a layer 3 device, because it's not a system which is used to route packets back and forth. It's just a security system we put in the network. So that's one reason we wanted to put it transparent, so there's no need for that device to route packets. The second reason would be that if it doesn't have an IP address, it means it's not reachable by the attackers, so it's stealth. And the third reason is that because it doesn't have an IP address, it means that to put the IPS inline in the network, you don't have to do a lot of changes or a lot of IP re-addressing in your network. But it has a routed port with an IP address just for management purposes, because of course you have to remotely connect to the IPS to manage it, to configure it, to update it, and all the management process. Now NIPS can be deployed as a dedicated appliance, so you're going to have a dedicated appliance, or as a hardware software module in another network device. We have two options to do NIPS with Cisco. And likewise, NIPS can be deployed either active in inline mode like an IPS, or passive, which means out of band like an IDS. Passive is also known as alert only, because if the IPS is being deployed in passive mode like an IDS, it means it can pretty much only alert as malicious traffic is detected. It cannot stop the attack from happening because it's not inline in the transit in the traffic path. So active mode means, as we stated, the IPS is positioned in the traffic path like we saw in the typical IPS design, and analyzes all traffic passing through and can take action and drop malicious traffic. While in passive mode, it's not positioned in the traffic path, it receives a copy of the traffic, and it has limited preventive action because it's like in the IDS mode. Now, of course, you might ask yourself then, why would I want to put the IPS in IDS mode? Doesn't make any sense. It does make some sense, because imagine that when you put the IPS in inline mode, it's gonna add a bit of latency to the traffic flow because it's gonna perform some deep packet inspections. And second of all, if you have a 10 gig link between inside and outside, if you put an IPS in there, you gotta make sure that it sustains a 10 gig constant throughput. It supports a 10 gig, like not line rate, but it supports analyzing 10 gigs per second, which that may be very expensive or not even feasible depending on which vendor you take the IPS system from. So on that 10 gig link, you may want to either put the IPS in line and only monitor some traffic, which is actually in general difficult to achieve but possible, or you may choose to put it just out of band, so like an IDS mode, and send all traffic to the IDS, because you don't, when the IPS is deployed in passive mode, it doesn't matter how long it's going to take the IPS to the IDS to analyze the packets, because not being in line, there's no latency being added, and you don't care if it gets overloaded or not in there. So different design options depending on what you want to achieve, and you got to make sure you take into account the network performance. That's why you may choose to put the IPS either in the active mode, inline, or IPS mode, or in the passive mode, which is out of band, which is going to be like in the IDS mode. Now functionality, so traditionally the IPS was used to detect both known and unknown attacks. So to achieve that functionality, it worked based on two main, let's say, features or capabilities. It had a set of rules, which of course were constantly updated, like signatures, which those were matching on known attacks. So if the IPS was seeing traffic flowing through, matching a signature, it knew it was a well-known attack and it was going to take action and drop the traffic. Or for unknown attacks, it worked through network learning, which is also known in Cisco as anomaly detection, in order to match on unknown attacks. Now, simple at a fundamental level how that worked. So you would put the IPS in the network. You would let the IPS to actually learn what traffic, how the network normally behaves, how traffic works in a normal way back and forth without anyone being infected. So then once the IPS is going to make like a baseline, a map of the traffic flow back and forth from and when in the network, then when an endpoint gets infected, clearly is going to start doing a lot of new things in the network, and IPS is going to say, well, I haven't seen that user doing this kind of traffic for the last 1 year or so. Something is suspicious, so it may be an infected endpoint in there. Now, it doesn't matter if you're running the IDS mode or IPS mode. So when an event happens, the IPS is going to trigger an alarm. So that's the capability to accurately, what we want is we want the IPS to accurately detect and generate alarms, and that's critical for the IPS functionality. Because of course, you would want the IPS to, if it's deployed inline, to block the attack. But at the same time, you may want to be let's say announced, or you want the IPS to log a message to tell you that an attack happened and has been blocked, because you may want to do some more analysis to see maybe the attack was partially successful or totally successful, or maybe the attacker is going to constantly try and still get in the network and perform other kinds of attacks. So you may want to do further analysis. So for that reason, it's critical that IPS is going to log a message whenever an event happens. Now, based on the inspected traffic and matching that traffic on the signatures or on the network learning functionality, we have two types of alarms. We have desired alarms. So that's going to be the type of alarms that we want the IPS to fire up. It's going to be true positive and true negative. And erroneous alarms or false alarms, which we wouldn't want the IPS to trigger those alarms, and those are called false positives and false negatives. Now, just like in the case of a NAT inside local, inside global, outside local, outside global, it's a big confusion in here, and people are trying to again memorize like what does true positive, true negative mean. They try to memorize up. We're going to define now what those four types of alarms mean, when do they happen, and then I'm going to explain you an easy way to not remember them, to understand them, because as long as you understand what each of those types of alarms are, the name of the alarm is going to tell you exactly in the end that what it does. So again, we want the true positive and true negative, and we don't want the other alarms, which is going to be false positive and false negative. So true positive, let's say true positive and true negative. First of all, those are good alarms because they have in here the true keyword. So if it's true, if it's a true type of alarm, it means that that's what I want the IPS to do. So true means that an event really happened. So and the IPS took action. That's what it means. So true means that there was an event happening, something bad happened. But then if it's positive or negative, true positive means that malicious traffic is detected, signature is matched, and alarm is fired. True negative means that normal traffic is detected, signature is not matched, and alarm is not fired. That's what we want. So we want when the IPS detects malicious traffic to fire an alarm. We want the IPS when it detects normal traffic not to fire an alarm. So the positive means that alarm was fired. Negative means alarm was not fired. So there you go. It's very simple. So positive means alarm was fired. Negative means alarm was not fired. And both of them are of type true because this is what we would want the IPS to do in general. This is a desired behavior. True means the correct action has been taken. Either positive to fire an alarm because a malicious traffic was detected, or negative not to fire an alarm because there's no malicious traffic detected. And then of course we have false positive and false negatives. And because both of them are of type false, it means this is not what we want the IPS to do. So it's a false response. It's a erroneous response from the IPS point of view. So false positive, it means that because it's positive, it means alarm was fired, but actually it was fired when normal traffic was detected. So it's positive, it means again that alarm was fired, but because it's false positive, it means it shouldn't be fired. So it means that a false positive shows up when the IPS detects normal traffic, signature is matched unfortunately, and alarm is fired unfortunately, when it shouldn't be the case. So false positives, it means, for example, to give an example of false positive, for example, let's say you have a signature, an IP signature which states that if somebody tries to authenticate to a telnet session 3 times in a row and it fails, then that could be an attack, because that could be an attacker from the internet trying to get unauthorized access to your internet router, for example. But of course, at the same time, it may happen that an admin connected to 3 a.m. in the morning to the router to manage it, and it may have mistyped the password 3 times. That can happen. So that's why it's so in that case it's a false positive, because the signature was matched. Because the admin has mistyped the password 3 times in a row and it has matched the signature, so alarm was fired. But it's a false type of alarm because there was no attacker. It was actually somebody who unfortunately sent traffic in the network and it matched a signature. But it was not an attack per se. It was just by accident that it happened. And then false negative. Negative means again that alarm is not fired. And it's a false negative, it means that it shouldn't be like that, because false negative means that malicious traffic is detected. And unfortunately, signature is not matched and alarm is not fired. So false negative means alarm is not fired, but because it's a false type of an alarm, it means that it should have been fired. Because actually malicious traffic was detected, was happening, but signature was not matched. So usually this means, for example, a bug in the IPS functionality, because you match a signature, but it's malicious traffic, but you don't fire up an alarm. That's unexpected behavior, right? But again, as you can see, if you understand what something does, false negative, false positive, and then if you look at the name of that feature, it is going to make sense. So you don't have to struggle to memorize false negatives, false positive. What is the difference? Just think about it. So positive means alarm is fired. Negative means alarm is not fired. True means I would want that to happen. True negative and true positive, so that's correct behavior. False means it's incorrect behavior. Which means, for example, let's pick up one, a false negative. So if it's negative, it means alarm was not fired. And because it's false, it means alarm should have been fired, which means that malicious traffic happened and signature was not matched. So there we go. If you understand what a feature does, and then if you look at the name of that feature, it is going to make sense. So you can easily know what each of those 4 alarm types are for. Now, something also which is important to IPS is the risk and threat rating. So we have to, once an event happens, we have to understand what is the risk level, how high is the risk, and what is the threat rating? How let's say malicious, how dangerous is that threat? Now, IPS generated alerts have an associated risk rating calculated based on, to keep it simple, the vulnerability. So what was the vulnerability which the attackers tries to make use of? What is the actual threat? And what is the target asset value? Now, an asset means anything of value to an organization. So when you're going to implement security policies, one of the things which you're going to do is that you're going to define the assets of your organization to associate them an importance level. How important, let's say how secure should be the assets of a type against assets of another type. Vulnerability means a system or design weakness that can be exploited by a threat. For example, an Explorer bug which could be exploited. The exploit means the actual computer code which was developed to take advantage of that vulnerability. So once we are aware of a vulnerability, we're gonna create a code which, if we deploy that code and we run that code on that system, is gonna take advantage of the vulnerability, and at that point unexpected behavior can happen, which means the attacker can take control of the user computer, or can reset the password, or based on the vulnerability other different attacks can happen. The threat itself is the potential danger to an asset. That's a threat. And risk is going to be the likelihood that a threat will exploit the vulnerability. So all of those are important and are being taken into account in the risk rating calculation. So if you look at this URL in there, actually they explain, of course, much better and more detailed how actually the risk rating value is being calculated. It takes into account the signature fidelity rating. So how fidel is that signature? How good is that signature? It's system predefined by Cisco between 0 and 100. The alert severity rating, which they say is the relative result or damage if the attack succeeds, which means we have 3 types information, 4 types: low, medium, and high. What that means is like how severe is that threat, pretty much. Does that attack present a low threat or a high threat? And then the target value rating, which, as the name states, what is the value of the target of the attack. And this is user defined. You're going to have to define in your network which assets are, let's say, more important, let's say, yes, more important, which means should be secured better than other assets. And you have like values of 74, 75 low asset value, medium asset 100, high asset 150, 200 mission critical. So based on all of those values, we're going to have the risk rating associated in there. And this formula in here, actually, it's not accidentally chosen. It has to do with how companies calculate the risk of specific attacks to their assets. Because in general, we're not going to secure everything in a network at the same level, because we have different kind of assets, different kind of informations. Some of them are publicly available, so we don't care if, for example, a PDF file which is publicly available leaks out. We don't care. So there's no need to invest money to secure from that point of view. But other assets may be more important. We want them to be up and running 100% of the time, close to be functional, so no denial of service attacks. And we don't want, for example, confidential files to be leaked. So depending on that combination of factors, the asset value, the threats, the possible threats, and the fidelity rating, we end up with a specific risk rating value for an attack happening against a specific asset. So based on that, we can take different actions. Now, of course, from back in the days, like nowadays, the advanced malware protection systems or sandboxing is being evaded or avoided by attackers, because attackers are aware that a lot of companies have sandboxing or advanced sandboxing, let's say, security tools in their networks. Back in the days with IPS, of course, the attackers knew about companies having IPS in the network, and they have deployed a lot of evasion techniques. So attackers use evasion techniques in order to bypass the IPS. Like, the scope is to result in false negatives. So they're gonna have they have a lot of, let's say, options in which they can send malicious traffic in a network, and even if it's gonna be inspected by the IPS may state that traffic is not malicious and allow it, which means it's gonna be a false negative. So it's negative, which means there's no alarm fired, because IPS states that traffic is not malicious, but actually it is malicious, so an alarm should have been fired because the signature should have been matched. And commonly used evasion techniques are going to be encryption and tunneling. So the attackers are going to try to bypass the IPS by sending malicious traffic within a VPN protected tunnel, which of course the IPS cannot decrypt traffic in there. Timing attacks. So we're going to see the presentation in another URL from a Cisco Press book in here. So timing attacks means that, for example, if the user starts scanning the network, if the attacker starts scanning the network, it means that if an IPS is being deployed and an attacker scans the network constantly, the IPS is going to take that's a scanning attack. And then what the attackers can do can change their scanning methodology to scan the network slower. So they're gonna scan 2 to 3 ports now, 2 to 3 ports 1 hour later, and so on. So they slow down the attack. So it's not gonna match that attack pattern is not gonna match on IPS signatures because it's a very slow attack, right? So timing attacks. Then we have resource exhaustion attacks. Like for example, resource exhaustion would mean something like their aim is going to be to put the IPS in 100% CPU, because if the IPS is overloaded, it's not going to be able to inspect any more traffic. So it means that they can sneak in their attacks in between if the IPS has no more resources to perform the packet inspections for all packets in there. So what that means is that they're going to fire up, for example, some kind of attacks that they know that the IPS is going to be busy, is going to be so busy to fire alarms. Like they're going to send specific attacks at a millisecond level or nanosecond level to make sure that the IPS is so busy to fire those very, very fast alarms that the CPU is gonna consume the whole CPU, is gonna cause a CPU hog, and the IPS is gonna left out of resources to do inspection for the actual packets where the actual attack is. Traffic fragmentation, so which means that the attacker is gonna send the attack fragmented in there. Protocol level misinterpretation or traffic substitution and insertion, both of them mean that the attacker is gonna somehow send malicious traffic, but at the application layer, at the payload layer, is gonna format that data in a non-standard format to try to and fool the IPS. You can read more about it in the next URL I'm gonna show you in a couple. But of course, Cisco has a fix, let's say, a tool to bypass all of those known evasion techniques. So we have countermeasures, anti-evasive countermeasures, which are built in the IPS. So to defend against fragmentation, then the IPS does full reassembly of the packet before inspection, because the attacker may split the attack in 5 fragments. So if the IPS would inspect each packet independently, it will not be able to spot the attack. So and for that reason, the IPS is gonna when it sees fragmented packets, is not gonna send them to the destination. It's gonna wait for all packets, all fragments to show up, rebuild the initial packet, and then analyze the whole packet, not each fragment individually. To defend against protocol layer, let's say bad formatting, we have the protocol and data normalization before inspection, and then protocol analysis to detect protocol standard violation. TCP checksum and TTL validation to defend against other kind of attacks with different TTL values in different packets being sent back and forth. Like an attacker could send the same attack, let's say the same malicious packet multiple times, but with different TTL values to try and fool the IPS to make it not be able to detect that attack in the packet. And also it summarizes the alarm for the same event. So it has a built-in feature that if the same event happens like 10 times, it's going to fire only one alarm to avoid against CPU resource exhaustion. So the URL I used is in here. This is going to be a Cisco Press book from the very old IPS fundamentals book in there, which is a very good book for just fundamental understanding of what IPS used to be back in the days. Because nowadays we use what is called NG-IPS, next generation IPS. Is nothing else but an evolved IPS required to defend against today's threats. So at a fundamental level, what it means is that the IPS adds contextual awareness to a regular IPS in order to protect against the full attack continuum. So as I stated, this is Cisco's vision, and I highly agree with them, is that to provide security for today's networks, first of all, you need defense in depth, and you need to be able to cover all phases of an attack mandatory, and you need the network, and you need to authenticate, authorize everything which is connected to the network, and you need contextual awareness. You need to understand who's connected, from where, when, how, what did they do in the network, and constantly monitor and log everything which happens in the network to detect any suspicious new traffic in the network. That's contextual awareness. But to translate that into facts, next generation IPS added features is that it can profile the hosts, so that if it profiles the hosts and does the network map and user identity tracking, it means that, for example, if the IPS detects an attack, which let's say it sees web traffic destined to a Linux box, and that web traffic is malicious, but actually is malicious only if the end system would be a Windows system or a Mac system, because the vulnerability is present only on Windows systems and Mac systems, not on Linux systems, for example. So because it profiles the hosts in the network, it does a network map, it's going to be able to actually not do a false positive, so fire an alarm even though there's going to be no let's say infected endpoints in the end. It's going to instead say, oh, so this vulnerability actually doesn't apply in this use case. This attack is not going to be successful because this is actually aimed to a Linux box which is not vulnerable to that attack. So it's not going to do any kind of alarms. It's going to be a true negative instead. It's going to do also network mapping and user identity tracking, because ideally nowadays you would want when the IPS fires up a true positive. So true means that it's expected behavior, and positive means alarm was fired up. It means that actually malicious traffic was properly detected. So when that happens, you don't want the IPS to just tell you, IPX from the internet attacked IPY from the inside with this kind of attack. You would want the IPS to actually tell you which user is on that endpoint, what the user did on that endpoint, what is the traffic flow, and also maybe if that endpoint got infected and if the infection has spread to other endpoints. So you want to have instant visibility for the after phase. The attack had happened, who got infected, what users were connected, so you know what remediations we have to do, because you have to go on those endpoints and not, for example, remediate the endpoint completely, but maybe just delete their user's profile and then allow him to log in again and create again the profile, because if you delete the user's profile, you're going to be able to delete most of the damage being done if it was done at the user level, not at the system level. You would want automated impact assessment, so the IPS to tell you exactly to automatically do an assessment of the impact of that traffic. Automated tuning, so you would want the IPS to, let's say, learn, to do a lot of learning by itself. Network behavior analysis, so to do network analysis as well. And application monitoring, which means to be able to actually detect if in a session over TCP port 80, is that HTTP traffic, or is it, if it's HTTP and if it's Facebook, is that chat traffic, is that video traffic, is that just browsing? So what is the micro application and what is the actual application at the application layer? So what kind of traffic happens back and forth? Now Cisco's NG-IPS products, we have dedicated appliances. We have the Firepower 7000 and 8000 series. or we have the software hardware modules, which are available as firepower services on the ASA 5500X series. And that module, the module with firepower services, actually has both NG IPS and NG firewall capabilities, and not only NG IPS. While the dedicated appliances of firepower 7000 and 8000 series are only next generation IPS dedicated. And we also have the iOS IPS as a license on ISR G2 series. Next generation appliance with unified code is going to be it. So the next generation firewall appliances with unified code, which means that's going to be the new devices which support both the firepower service capabilities, so NG IPS and NG firewall, and the ASA firewall capabilities under one unified code. And that's going to be the firepower 4100 series and 9300 series. To manage the NG IPS, we're going to manage it through the Fireside Management Center or to the Firepower Management Center. Now, the Firepower Management Center is the new version of Fireside Management Center, which, as opposed to Fireside, Firepower can manage multiple systems. It can manage next generation firewalls policies, next generation IPS policies. It can manage dedicated appliances. It can manage also the ASA with Firepower services. It can manage the firepower services on the ISR routers called Firepower Threat Defense, and it can also manage the advanced malware protection on the endpoints.